Yeah.
It's
You can start the session.
Thank you, Kathy. Thank you, all dear participants. Now, let me share my screen. Can you please confirm, Kathy, whether it is visible or not?
Your screen is yet not visible.
Okay, I will
if you
share.
have shared. Yeah.
Whether it is visible now?
Yeah. Now it is visible and you are clearly audible. You can start.
Okay. Thank you, Kathy. Thank you, dear participants. So today we are going to discuss about one of the supervised machine learning technique called regression. How many of you know or aware about this regression? Can you please put some reply in the chat? Regression or any supervised classification or regression or anything. Anyway, today we will go through the entire concept of regression and also two hands-on programs we have today. Okay, thank you. First of all, we'll discuss about what is supervised machine learning. Actually, there are mainly two types of machine learning. You might be knowing about that. What are the different types of machine learning technique? We have machine learning can be divided into three types, mainly three types. First one is supervised. Main type of machine learning is supervised. Second one is unsupervised, and third one is reinforcement machine learning. These are the main three types of machine learning technique. Actually, there is two diagrams here. One represents the supervised machine learning and one represents the unsupervised machine learning. From the diagram itself, it is clear that this is the example for supervised machine learning, which is nothing but there is a supervisor or there is a mentor there. There is something, someone who is supervising us to learn about something, right? That is supervised machine learning. Okay, then from this diagram, it is clear that there is, this is self-study. There is no supervisor. The same student is learning something himself, right? There is no supervisor. So that is the concept of supervised and unsupervised. This is supervised, this is an unsupervised machine learning. Actually, today we are going to discuss about one of the supervised machine learning technique called regression. Why it is supervised? Why machine learning is supervised? Why regression is supervised? Any idea? Because there is actually there are mainly two different concepts for it. Consists of, first one is make supervised is nothing but it consists of labeled data. It have some labels. What is meant by machine learning? What is the concept called machine learning? Machine learning is nothing but it is a subset of the computer science field called AI or artificial intelligence. It is nothing but what is meant by artificial intelligence? Artificial intelligence is nothing but we are making some system artificially intelligent. How we are making the system artificially intelligent? Whether we are saying to something to system and then the system become artificially intelligent? No. Whether that is the procedure? No. For making the system artificially intelligent, it should learn something, right? So by using the machine learning algorithms, we are going to make the system artificially intelligent. So that is a set of algorithms. Okay. So in the case of supervised machine learning, it consists of labeled data or it predicts. So there are two types of tasks for supervised machine learning. That is prediction of label or value of any unseen data. Okay. So how supervised ML work? Here the concept of classification is explained here. This is the concept of supervised machine learning. Here some labeled data is here. Already this is the model we have developed using some machine learning algorithms. There are a number of classification machine learning algorithms. For example, SVM, random forest, decision tree classifier, logistic regression, naive Bayes classifier, then K nearest neighbor classifier, a number of classification algorithms we have. Okay, using that classification algorithms or machine learning algorithms, we need to develop a model. That is, this stage, we are going to develop a model using machine learning algorithms. For that, we not only need this machine learning alone, we have to use some set of data. Actually, we are using labeled data for model training. Actually, this is the concept of data set here. It consists of different images having different shapes. So here this is an example for hexagon, square, and triangle. So actually, this model is trained using the data set with the labels hexagon, square, and triangle. Then the model is learned, the model able to identify any unseen test data with the same features, of this square and triangle. It is able to predict whether that is a square or whether that is a triangle. So in this stage, for construction of this machine learning model, we have to use two different concepts. One is the algorithm, that is machine learning algorithm we have to use in this stage. Another one is labeled data. Okay, fine. So how machine learning works? Learn based on the category or value of input based on features. The model shown here recognize the category of the, so after this stage, this model is able to predict what is the category of this test data, that is unseen data. That is the concept of supervised ML. There are mainly, we are going to discuss this type of supervised, that is regression problem in detail today. So types of supervised ML. It consists of two different types. First, one is regression, another one is classification. Regression is, what is the difference between regression and what is the difference between classification? If you are going to solve a real time problem, we need to identify which type of algorithm we need to use we need to implement to solve that particular problem. So based on the problem, we need to use regression or classification algorithm. For example, I will tell two scenarios. Actually, I want to classify the customers based on their characteristics or visit to some supermarket. I need to classify the customers as frequent customers or rare customers. That is one scenario. Another scenario is I need to predict the value of a second-hand house. For the first scenario, which algorithm we are going to use? First scenario, I need to classify the customers as a rare or frequent customers. In that case, we are going to use the algorithm called classification algorithms, because I need to classify the customers, right? I need to assign some labels to the customers as frequent or rare. That concept of solving problem is called classification algorithm. Okay. In the case of regression, the output of classification will be a label associated with, or class associated with it. Okay, the output will be a label or a class. Okay, but in the case of regression, the output will be a value. The output will be a value. In the case of, if I want to predict the value of a second-hand house based on the data I have, what type of algorithm I need to implement? Obviously, that is regression algorithm. I need to predict the value of the second-hand house, right? So that is the concept of, that is the different types of supervised algorithms. So from next slide onwards, we are discussing about the concept called regression. Regression is nothing but, I have already told you that regression is nothing but the numerical prediction of some input, right? Numerical prediction of some input features. Based on the input features, the regression algorithm should predict some numeric value based on the already given data. The major method for prediction of numerical value is regression. Okay, so first we have to go for what is meant by linear regression. What is meant by linear regression? It consists of two different types of variable, that is dependent variable and independent variable, that I will explain later in detail. This is the concept of linear regression. We want to predict the value of x. We want to predict the value of y. We have x with us, and based on the data set we have calculated the based on the algorithm, we have the value of m. M is nothing but the slope, and b is nothing but the y-intercept. We have calculated the coefficients called slope and y-intercept, which are called the regression coefficient. That is the concept of regression actually. We have some data set with us. Data set, I have already explained that in the case of supervised ML, it consists of some labels. Features are called the x values or input values, and the labels are called y values. So based on the already given x and y values, we have to find out the values of y-intercept and slope. Okay, based on the computed value of y-intercept and slope, if we have a new or unseen value of x with us, we can use this y-intercept and slope value, and we can find out the value of y. That's the concept of linear regression. So training data set, compute the value for m and b coefficient. Based on the training data set, we are going to compute the value for m and b. M is the slope and b is the y-intercept. Then testing data set, compute the value of y using m and y. Using m, y and x, we are going to using m, b and x, we are going to compute the value of y. Okay, there are different types of regression algorithms we can use: linear regression, logistic regression, polynomial, support vector, decision tree, random forest, rigid regression, and lasso regression. In this class, we are going to explain the most common type of regression called linear regression. Okay, so in which areas we are going to use regression? Actually, regression can be used for predictive. Mainly, it is used in the area of predictive analysis. As I already told, if I want to predict the weather, tomorrow's weather, it is a numerical value, right? Weather. If I want to predict the temperature for tomorrow, that is a numeric value. For that, I need to use regression algorithm, right? Then operation efficiency of a particular any particular instrument. Then supporting decision, we can find out some supporting decisions, correcting errors, and if you want to produce some new insights into a problem, that can also possible through regression. Mainly it is used for the application called predictive analytics. Okay. But then from the data set, from the case study point of view, we are going to analyze what is and exactly is regression. Actually, here it consists of a data set. Here I have some X value with me. This is the Y value actually. That is CO2 emission is the Y value. This is the X value. Okay. Actually, here in the last row, that is the unseen X, I need to find out the CO2 emission based on the already given data set. This is the concept of regression. We have this much of, this is X with S and this is Y with S. Based on this X and Y values, we can able to calculate the slope and intercept value, right? Based on that slope and intercept value computed using the already given X and Y, we need to find out the Y value for this given X value. For this type of applications, we are going to use the concept called regression. Okay. Then types of regression variable. Actually, we know there are mainly two types of regression that we can use. What are the two types of variables? One is dependent variable. What is from the name itself, it is clear, right? What is meant by dependent variable? Depends on something, right? Actually, we are going to find the value of Y using the value of X, right? If we have the features, then we are going to find out the output, right? So in this case, Y is the dependent variable which depends on the independent variables X. There is only one dependent variable Y, but there are more than a data set may consist of two or more independent variables, right? So there are two or more independent variables in the case of regression. So dependent variable is Y, which depends on X. Then independent variables are the features or X values. Okay. The types of regression model. Mainly, the linear regression can be divided into two types, simple regression and multiple regression. This is nothing but it is based on the number of features. Actually, if you are going to find out the value, if you are, I will explain about one scenario. If you are going to find out the salary of an employee based on only the years of experience, then that if you are going to find out the salary of an employee based on only single feature, that is based on only the years of experience, then that particular type of regression is called simple regression. This based on only single feature called years of experience of that particular employee, right? So in another scenario, if I am going to find out the salary or predict the salary of an employee based on the years of experience and his education. Two features, years of experience, his education, and also his position. Okay. If we are using these three factors for finding out the salary of a particular person, then or a particular employee, then that particular type of regression is called multiple regression because it uses 2+ features or more than one features are used for finding out the salary. So that is the concept of multiple regression. Regression can be linear, simple can be linear, non-linear, multiple can be linear and non-linear. Okay, it's the concept of simple regression and multiple regression. Linearity depends on the relation between regression dependent and independent variable. It can be either linear or non-linear. It is the linearity of a regression model is mainly depends on the relation between the dependent, that is how y is changing based on x. That is the concept of linearity. Then what is meant by, what actually is the linear regression model? If I have two data points with me, this is one data point and this is another data point. This is nothing but xy values. Okay, I have two features with me. 2, 4 is one point and 5, 10 is another point. If I am going to apply some regression algorithm for this data set, what actually regression model going to do? Actually, it is nothing but drawing. Regression algorithm will draw a line that is as close to every dot as possible. Actually, there are number of options here to plot this line, right? I have two data points. One option is we can plot line like this, right? Otherwise, we can plot line like this, right? Then line like this, line. Anyway, we can plot the line. This is the line that can draw with two data points most closer, right? So for classic linear regression or linear least square method, you only measure the closenesses in the up and down direction. Up and down direction, the linear regression algorithm find out the closenesses of the data point. Actually, when we are applying a regression algorithm, actually what happens is the regression algorithm will draw a line. So that is why the concept of regression is related to the equation of line. What is the equation of line? Y is equal to mx plus b, right? So the regression algorithm will draw a line based on the condition that every data point should be most closer to the this regression line. That is the concept linear regression using. Then what happens if there are multiple data points? We have considered only two data points, but here we have multiple number of x and y's are there, multiple data points, number of rows we have. The points increase. How the points going to increase? If we have 100 rows of data with us, we have 100 points with us, right? It consists of x and y values. Okay. So fathers, this is the relation between the father's height and son's height. Whether the son's height depends on the father's height. That is the problem we need to solve here. We are going to predict the height of the son based on the value of father's height. Okay. This is the idea behind supervised learning. What happens if there is multiple data points? This is the situation we are going to handle in the case of regression. Okay. So in the case of linear regression, what is our goal after implementing a linear regression algorithm? That regression algorithm should be able to determine the best line. For that, how we are going to determine the best line? We are going to determine the best line based on the, we have to find out the most optimal value for the coefficients, intercept and slope. That how we are going to determine the best line. So our goal is to minimize this distance between the line and rest of the data points. So this is the optimal line we can draw using regression algorithm. So in this, the distance between the data points and the line is more closer, right? So that is the concept of linear regression. Then the question is another situation. Given in this data set, can we predict CO2 emission of the car using another field core engine sites? Yes, we can predict. There is one. This is nothing but this is the concept called simple linear regression. We are going to predict the value of Y, CO2 emission, based on the independent variable. X is the independent variable and Y is the dependent variable because Y depends on value of X. Based on the value, X value, we are going to predict the value of CO2 emission. Okay, that is the concept of simple linear regression. The simple linear regression. Plot our variables. We have to plot our variables here. Engine size, here engine size is the, as we already explained, engine size is the independent variable. Then emission is the dependent variable we would like to predict. A scatter plot clearly shows the relation between the variables. We have plotted yesterday, I think Alok have explained about different visualization technique. In that there is a type of plot called scatter plot. Based on the scatter plot, we can find out the engine size. Here it is able to find out that if the engine size is low, the emission is also very low. When the engine size goes higher, the emission, CO2 emission, is also very high. That is the relation between the engine size and emission, CO2 emission, that can be analyzed from this particular scatter plot. This scatter plot clearly shows the relation between the variables. Also, it indicates that these variables are linearly related. So, this is a simple linear regression. What is linearly related? As X increases, Y is also increases. That is the concept of linearity of a particular line. Where X increases, then corresponding Y is also increased. So the scatter, this concept, this scatter plot. From this scatter plots, we can analyze the characteristics of data points and the relation between engine size and emission. So from this, we are going to find out the y-intercepts and slope value. Okay, so engine size increases, so do the emissions. So let us assume for a moment that the line is a good fit of data. We have to plot a regression line. That is our aim. So we can use it to predict the emission of an unknown car. Okay, if we have engine size of 2.4, this is going to predict. If we have unseen data, engine size of 2.4, we can set for the data set here. We have 2.4 here, right? Engine size of 2.4 here. Based on the regression line, it predicts the value 214. Then it may not be exactly as the actual value, but it will be closer to the actual value. So here it is 221, but our regression algorithm predicts that it is 214. This is the concept of regression. For 2.4, we have predicted the emission value 214. Okay. Then simple linear regression in the mathematical foundation. Actually, now the questions are: how would you draw a line through the points, and how do you determine which line best? Linear regression estimates the it is through estimation of the coefficient. We have two coefficient with us. This is the independent variable. This is the y dependent variable, which depends on the value x. So we must calculate the slope and intercept value, that is theta 0 and theta 1, to find out the best line to fit the data. Based on this theta 0 and theta 1, we are going to find out the best line to fit the data. So we are going to adjust the parameters that make the line to best fit for the data. We are going to adjust the parameters. Based on these parameters to be adjusted such that the line, regression line, should be closest to every data point, and it is also a very optimal line also. So we have to assume that we have already found the best fit line for our data. So the best fit line for our data is this one. Actually, the best fit here means that if we have the predicted value very close to the actual value based on the historical, if we have some actual value with us and also some predicted value with us, then the error is 90. Here the predicted value is 340 and the actual value is 250. Then the difference, error, is 90. So we have to find out the error value. Best fit means that if we have predicted value very close to the actual value based on historical data, in fit line using our polynomial, we give a different value. This may be error in actual value and predicted value. This means that our prediction is not accurate, and this error is called the residual error. Here the 90, the value 90 is the difference between actual value and predicted value. Here the actual value is 340 and the predicted value is 250 here. There is a difference of 90 here. This is the residual error which happens during the regression prediction. So our aim is to reduce this error value such that we have to find out an optimal solution for the regression problem. Okay, performance. Then another performance evaluation. Performance evaluation using MSE. MSE is nothing but mean squared error. That means we have to, after predicting the value of unseen X based on the value unseen Y, based on the value, we have to predict the value of unseen X and we have to predict the value of Y. We have an actual value yi with us and we have some predicted value with us. So we have to find out the error rate called MSE. What is our aim is that we have to reduce the mean squared error to find out the optimal regression line. Okay. So performance evaluation using MSE, that is mean squared error, that is the famous performance evaluation metrics that can be used for regression. The objective of linear regression is to minimize the MSE equation, and to minimize it, we should find the best parameters. How we are going to minimize the MSE value, that is mean squared error? We have to find out the best parameter values for y-intercepts and slope value theta 0 and theta 1. We have to find out the best value for theta 0 and theta 1 based on the MSE value. We have two options here. We have to use a mathematical approach to find out the best parameter values for theta 0, theta 1, or we have to use some optimization approaches for that. So what is our aim? Based on the existing data set, we need to find out an optimal value for y-intercept and slope. Based on that y-intercept and slope, only the accuracy of the prediction using linear regression depends on the optimal value of the y-intercept and slope values. Keep that in mind. Okay. The mathematical approach is calculate the mean of the independent and dependent or target columns from the data set. It can be shown that intercept and slope value can be calculated using these equations. We can start off by estimating the value of theta 1. Here, there is a case study for this one. We have, what is here? We have some X values with us and we have some Y values with us. This is the equation to find out Y, right? We have X minus X bar. X bar is nothing but this one. Here, considered here, engine size here. So theta 1 is going to calculate. We have to find take every xi. Xi is nothing but 2. X bar is the mean of 2. Yi is nothing but 196. Y bar is nothing but the mean of up to this value, this one. Then xi minus X bar. Okay. Using this equation, we have to find out the theta 1. So here X bar is the mean of this column. We are going to calculate the mean of this column, that is 3.34. Then Y bar is nothing but the mean of this column up to 267, that is 256. Based on one, here it is there. So theta 1, we are going to find out first one. We are going to find out 2. 2 here. 2 minus the mean is 3.34, that is 3.34. Here 196 minus the mean is 256 here, 256. We have to repeat the addition up to this row. Okay. So the numerator is okay. Denominator is nothing but 2 minus then mean 2.4 minus, and we have to find out this sum of this one also. From that we will get the optimum value of theta 1 as 39. Okay. Theta 0 can be found out using theta 1, that is y bar. Y bar is nothing but 256. Theta 1 we have calculated, that is 39. And x bar is nothing but 3.34. Based on this equation, we can find out theta 0, that is 125.74. So we have 2.14 with s. We have 2.14 with s, that is x1. We are going to calculate the y for the unseen value 2.14 here. We are going to find out the unseen value 2.14 here. So we have to substitute all the values. We have this one 125.74 as what is 125.74 as theta 0. Then 39 is theta 1. Then x1 is the unseen value 2.14. When we are substituting this one, we will get the value of 218.6 as the predicted value. Actually, what is our actual value? Actual value 2.14. The actual value is 221. There is no much difference. 221 minus 218.6 is actually only difference is 2.5 only. So we have reduced our MSE, that is mean squared error or residual error rate, to 2.5. So we have find out the optimal value based on the mathematical approach. That is by finding out the coefficients based on the mathematical approach. What is multiple linear regression? What is actually multiple linear regression? As I have already explained, if we have one or more, we have more than one features with us to predict the value of y, that we have now we have covered the concept of predicting the salary of the person based on his years of experience only, right? Now we are going to predict the salary of an employee based on the years of experience, his designation and his education. We have three features with us. In that case, we have to use the concept called multiple linear regression, since we have multiple features with us. Okay. So when to use multiple, examine which variables are significant predictors of the outcome and how each feature impacts the output variable. So this is the x value with us and this is the y value with the same example. We have now we have used only the engine science to predict the CO2 emission, right? We are going to use more than one feature, that is cylinders and fuel consumption, also for predicting the CO2 emission. In that case, that particular type of regression is called multiple linear regression. Mathematical foundation, there the in the case of simple linear regression, the mathematical equation was theta 0 plus theta 1 plus x1. Here the y, the output is going to calculated, computed using the equation theta 0 plus theta 1. There are multiple features like x1, x2 and xn. Here we are going to use this equation. Okay. Then performance evaluation using MSE, we can find out the performance evaluation in the case of this multiple linear regression. Also same concept. We have to find out the difference between the predicted value and actual value. The performance evaluation metrics is same for both simple and multiple linear regression. That is the concept of linear regression. If we have any doubt, we can ask now. Otherwise, we can go for our hands-on session. You can. Shall I move to hands-on session? Can you please confirm? In the chat. Okay, thank you, thank you. I'm stop sharing this screen. Okay. Now, I hope that everyone have your Anaconda installed with you, because yesterday you have some hands-on session, right? We have to use same Anaconda software for hands-on session. Actually, I have posted some data set with you. Okay, have you gone through that salary data and car data, whether you have received? Can you please download and save your data set? I will provide the procedure how to use in Anaconda software. Can you please confirm? Have you received the data set? Okay, here it is. First chat I have shared the data set with you. Okay, so I will share my hope everyone is. I will close the. If anyone don't have Anaconda with you, no, you didn't receive the data set. I will.
इससे होता है क्या? रोमिंग चार्ज लगते हैं उससे. अरे भाई
Have shared the data set again. Whether you have installed Anaconda software in your system, can you please confirm in the chat? Otherwise, I will provide the link to download the Anaconda software. Actually, in the prerequisites, it was there. Yes, we have. Okay, fine. Then I will share my screen. You have to go to take your Anaconda navigator like this. Okay. Now take Anaconda navigator. From this tab, you have to launch Jupyter Notebook. Okay. Launch Jupyter Notebook. I have launched the Jupyter Notebook. Then, if you want to upload, I have provided two datasets with you, right? If I want to upload that, we have to upload your dataset in this Jupyter Notebook environment. Please, after launching the Jupyter Notebook, one tab is here. Can you able to view this tab, Upload tab? You have to click that Upload tab, and you have to upload the dataset like this. After downloading the dataset, you have to upload your dataset like this. Okay. Then car.csv, we have to click upload. So the car.csv dataset is here. Car.data CSV dataset is uploaded here. Okay. Then I have to upload another data set also, salary data. That is also you should upload here. I have already salary data. If you have already salary data with you, you can override that one. Otherwise, you can click the upload button. Okay. So your data set for regression hands-on is ready with you. After that, you have to click this new tab. Okay, for Python 3 and select Python 3 IPY kernel. Then you are going to open it. There is one new notebook opened here. You want to rename that one. We can rename that one regression underscore. I am going to rename is MIT here. Okay. Now we are going to start our regression hands-on. Now we'll go for simple regression hands-on here. So before that, actually we have multiple libraries. We have to import all the needed libraries here. So we are going to, what is our problem actually? We are going to predict the salary. That is the problem we are going to discuss today. Predict the salary of an employee based on the years of experience. Okay. We are going to do today. So for that, we have to import some necessary libraries. Import some necessary libraries here. Import libraries. Here are the different libraries we have already studied. We have to import pandas library for handling with files yesterday, as Alok said. So then we have to import, for dealing with arrays, we need to import NumPy library. For data visualization, we need to import library called matplotlib library. Then for using the machine learning algorithms, I am using it from the library called sklearn, that is scikit-learn library. Scikit-learn library I need to import. So the different libraries I need to import for our program. So I'm going to import that particular library, which is the command used to import the libraries. So import pandas library. Import pandas library. I have imported pandas library SPD. Okay. Then for using pandas library, I need to, can you please do this with me, this hands-on? Import pandas SPD. I have imported pandas library. I need to read the data set. I have used a which is the data set I have uploaded here. Salary, for salary data set, I will show the data set for you. I have salary with CSP with me. So years of experience consists of two fields. First one is years of experience and second one is salary. Okay. So I need to I need to read that salary data set based on which one, to the variable I am going to read the salary data set using the pandas library. I have imported pandas SPD. PD dot, the command used to read the data set is read CSV. Okay, read CSV salary dot CSV. Okay, I can read the data set. Then I am reading. I am displaying the. Can you please mute yourself? Some disturbances. Hello. Thank you. So what I have done here, I have imported the libraries called pandas here, pandas library here. Then I have imported pandas library using the pandas library. It is imported. Is the aliasing is used here pd dot the command read CSV. I have read the data set called salary. This is the data set I have uploaded. It consists of 2 columns, years of experience and salary. Based on that, I have and I have print the head. Head is nothing but for this is a command used to print the first 5 rows of the data set. If I want to print first 10 rows, I have to see default it will print the first 5 rows. If I want to print the first 10 rows, this is the 10 rows. Actually, it consists of if I want to print the entire data set, I need to print df. So if I want to print the first 10 rows, I need to print like this. It consists of years of experience here and salary here. Salary I have displayed here. Next, we have this one. We have some years of experience and we have some salary with us, right? So I need to predict the salary of unseen years of experience. For that, we have to visualize our data set in a scatter plot based on the matplot library. So I am going to import the library called matplotlib dot from that I am taking pyplot. Okay, plot. I am scatter plot, going to scatter plot this salary data. Plot dot the command used to plot the scatter plot is scat of df. I need to plot this one, right? So this one is years experience, right? The column name, we have to give this column name here, years experience here. We have to give the column name here, years experience. Then here the column name is salary, right? So I need to give salary here. So based on this, I am going to here I have imported from matplotlib.pyplot. I have imported plot pyplot as plot dot. I am going to scatter plot this data set here. So what is the command used to display that plot? Plot dot show. This is the scatter plot of the data set. Okay. This is the I have salary data with me. So I have read the data set and displayed the values, and also I have plotted a scatter plot. This is the application of the libraries, different libraries you have studied yesterday. You have studied yesterday about NumPy, Pandas, Matplotlib library, right? So this is the application of that particular library we can use when we are going to solve a problem. We can use that particular libraries to visualize the data set, and based on the visualization, we can find out the apt solution for that. Then we need to set the X and Y values. From this one, the years of experience should be set as X, right? And the salary should be set as Y, because X is the salaries depends on the value X, right? So I am going to use the command df dot iLocation values. Then YS, this is the zeroth column. Zeroth column is nothing but the years of experience. Zeroth column this should be set as X, years of experience. I want to set the first column, that is salary, as Y, that is the label. Okay, so I'm going to set one here, dot values. So I need to provide column. This is the formula for assigning features. X feature is nothing but years of experience and Y is nothing but salary based on years of experience. I have set X as the years of experience and Y as the salary. Okay. So then we have to, based on the linear regression, I need to find out the two coefficient values, x-intercept, y-intercept, and stop value, right? So I need to import the algorithm for linear regression. So for that, from sklearn dot linear model, I am going to import the linear regression algorithm from the library. sklearn is nothing but scikit-learn library. Then linear model, I am going to import the library or linear regression. Okay. Then taking the instance of the model into a variable called model, linear regression, imported linear regression. This is the regression algorithm. Okay. Then I'm going to, for finding out the coefficient values, we have used the command called fit command, that is importing linear regression. Regression model.fit command I am going to use. So x comma y. Okay. So the linear regression executed. Now our coefficient values are calculated based on x and y values given here. Okay. Then we'll have to find out the slope m and y intercept. Okay. Here, what is our regression equation? Y is equal to mx plus c, right? So here m is what? M is slope, right? M is slope and C is y-intercept. Okay. So based on this fit command, we have calculated the optimal values for, actually I have explained about the concept of the value. So actually based on the linear regression algorithm from scikit-learn library, it is able to find the optimal value. So we no need to do anything. It will find out the optimal values of slope and y-intercept from the already given data based on the mathematical approach. Okay, we are going to print the slope value. Slope value m is equal to, is already calculated using the fit command, model dot coefficient. So print M. So M is 9449. This linear regression algorithm, and using the FISC command, the algorithm is able to calculate the value of M. M is nothing but the slope plus 9449. Then we need to print the y-intercept C, right? C is equal to, that is also. Actually, this algorithm algorithm along this FISC command and using X and Y, it is able to find out the value of M and C. We no need to provide any equation or any computation inside this, that we need to keep in mind. So model dot intercept printing the y-intercept. Okay, model dot interception, we can able to find out print C. Okay, so this is the value of y-intercept, that is 25,792. If I want to predict the value for 1.7, actually, whether we have 1.7 with us. No, 1.7 is not with us. Right? If I want to predict the salary of the person having years of experience 1.7, here is only 1.5 and 2 with us, right? We have 1.7 and 2 with us. It should be something. The salary should be something between 37,731 and 43,731. Let us predict based on this algorithm we have developed here. So I am going to predict the salary of the employee having experience 1.7 based on the algorithm we have developed. What is our model? We have model dot predict. I'm going to predict the value. So 1.7 value of is years of experience having 1.7. So I am going to predict that value. That is 41,857. Where we can go check with the data set. It is almost correct because the employee having 1.5 years of experience having salary 31,731, and the years of the employee having years of experience to having the salary 43,525. This is something. So the employee having years of experience between the year 1.5 and 2. Should have salary between 37,000 and 43. Almost it come like this predicted like this only. It is predicted salary is 41,857. That is almost correct according to our data set. Okay. So I want to predict (3.6). I am going to predict 3.6. Let us find out what will be the, okay. 3.6. $59,812. 3.6. This one. The employee having years of experience 3.6. The salary will be 59,812. We can check with the data set. 3.63 having 3.7 having 57,000. That's why it is predicted as 59,000. So it is almost correct. So that is the concept of linear regression. We have developed a model based on already given X and Y. Then we are able to predict the salary of the employee having years of experience, which is not in the data set. That is almost correct. Okay. Then we can go for multiple linear regression. Actually, time is 3:10 now. So can go for then if you want to find out the error value, actually I have explained about some error value, right? So for that I need to import some library called from sklearn itself. I need to import some library sklearn dot matrix import I want to find out the y underscore predict here. What is the predict? Means y underscore predict. I need to find out here. Y underscore predict should be. I am going to predict here. Model dot predict. I have x with this. We have going to find out x with this. Predict x. Okay. So then we are going to find out the mean squared error using this y underscore predict. Okay. So print y comma square should be minus yes, the mean squared error is 5,592. So we have we can evaluate the performance of our regression algorithm based on this mean squared error. So we can go for some other algorithm for this one. So another type of we can use another type of algorithm here. So here I have used linear regression here. So we can compare our result with this some other algorithm. So I am going to import another type of regression algorithm from sklearn. Linear model. sklearn.linear model. I am going to import. Previously I have used linear regression algorithm. Here I have using some other algorithm for same problem. Then we can compare the result with this linear regressor, SGD linear regressor. Then I am taking the instance here. This is the name of the algorithm we have using here. So we can compare the result based on the value. What will be the value? Based on the value of mean squared error. Okay. SGD. I have to follow. I have used this one model here. So I have to follow the same steps for SGD regress and fitting the model. We have to run this one. Somewhere is there. Okay, the output is given here. So then I have to print the model coefficient using SGD regression. The model coefficient is 10,472. Here the model coefficient was 9449. We can check the result actually. Then we are going to print model intercept for using SGD regression. We are going to compare the result with using two different regression algorithms for the same problem. The intercept value is 18,452. Here the intercept value is 25,792. Then we can this one. We can predict the value of this years of experience having 1.7 here. So I'm going to predict that one. That is 36,266 actually. Here 41,857 only. So we can check with this one also, this one error rate also. So the error rate, the mean squared error is high for when we are using SGD regression. The error rate is high. So from this comparison, we're using same salary prediction using prediction using years of experience. We have used two different types of regression algorithms. First is linear regression, another one is SGD regression we have used. From the calculation of mean squared error value or performance evaluation calculation, we can conclude that for this problem, the linear regression we can use, the best performed algorithm is linear regression, since the error value is only 5,592. In the case of SGD regression, the error value is higher than when we are using linear regression 6557. Then quickly we can go through the multiple regression also. Multiple regression also using that car data. Multiple regression also we can go through. We have another data set with you, right? That car data using that multiple linear regression. Car underscore data. Otherwise, he can give us data is equal to, you have to read that data set, right? Read of read underscore CSV. Car.data dot. Okay. Now, what is our data set? We need to cross check with the data set name. It is car underscore data. We have to use the same name here, car underscore data. So this is the car data. We have to find out the selling price based on different. Here from this data set, it is clear that there are more than one features for predicting the value of the selling price, right? So we are using this is the concept of multiple linear regression. Based on multiple features, we are going to predict the selling price of a car. Okay. So for that, so we have to perform the train test split here, sklearn dot. So from sklearn, we need to model selection. First, we need to split x and y values for model selection. Import the library called train test split here. Okay. So we need to find out 4 different tasks, right? X underscore train, comma, X underscore test, right? Y underscore train, comma, Y underscore test. You have to use the function called train results and split. We have used before that we need to set the value of x and y. X is equal to data dot draw other than, we are dropping the column that selling price, because that is the y value. We are dropping that particular column. Other than that particular column, we are assigning excluding that particular column, we are assigning the values of other columns as x. Okay. So x is equal to 1 we have to give. So we are going to X dot we have to print, we can print the first 5 values of X. Like that, we need to assign the values of Y. Y is nothing but the selling price, right? So we need to give data of selling price itself. Data of selling price. Data of selling price. Data of selling price to this one. We can print this one also. Y dot head also we can print. Sorry, we have to give a column here. Okay, Sarah. So one. This is one. So this is selling price. This is Y value here actually. So okay. So X is assigned, Y is assigned. Then we have to split X and Y values. We have to use X, Y. Then the test size, we are actually normally we are using the test size is 20% of the data set. So we are specifying as test size is equal to 0.2, that is 20% of the data set. Then we are providing some random set how it need to select the seed value for selecting the random test data set. So we have to set random state is equal to 1. Okay. So we have set X train, X test, Y train, and Y test here. Okay. Then we need to we have to import same linear regression here. Okay. Within 5 minutes, I will conclude. Okay. So run. So we have the same function we have to use for multiple only X and values only changing. Okay. So then say we have to the setting of X and Y values the only change in multiple regression. Other than that, there is no other changes. So we are selecting the instance of linear regression into the variable model. Okay. Then
we are doing or not, we should, this is after discussion.
model dot
Yeah.
please mute yourself. Please.
उधर बंद है किताब तो अच्छी है, उधर अगर खुल गई यहाँ की किताब तो बहुत अच्छी है।
X train and Y train we have to use here.
लांडगा अलग है।
what's happening? Model dot fit space 7. X underscore trainer, Y underscore trainer I have used here. I don't know what is the
Ma'am, I have a doubt.
okay. Can you please ask?
Here, test size equal to 0.2. That means
The test size is actually we have used 0.2 means actually what we have to do is we have a data set with us, right? We have suppose we have 100 data set with us. Consider 100 we have 100 data items with us. So we want to divide. We have to use majority of the data for training and some data for testing. We have to divide the data set. We can divide the data set according to our wish. We get some we can divide it as 30, 70 or 20% for. So 20% of 100 means 20 data items, right? So we are setting the value as 20%. That is, we are giving 20%, 0.02 here. So we are taking 20 data items for testing. We have considering only 80 data items from the data set for training purpose, training our linear regression model. So for testing our data set, we are using the 20 data items, remaining 20 data items. Okay. Hello.
yes, ma'am.
Have you understood?
Yeah.
Okay, okay. You can give 0.3 also, then 30% will be used for testing. Actually, for what we have to use is we have to analyze the performance evaluation, right? Performance evaluation. So we need to know the actual value of Y. We have to compare the actual value of Y with the predicted value. Then only we can provide the performance evaluation of our model. For that, we are using some data from already labeled data from our data set for testing. We are using. For that, we have used. Actually, model.fit we have given like this, like why I don't know what happens here. So X train, X test, Y train, Y test. Anywhere train test it's 5, test size is equal to random, set is equal to 1. We have to fit the model with the X train and Y train. Then we have to, I will correct it and post it in the group. Okay, actually the time is already. So some float value error is there actually. We'll correct it. Then then we have to use the command called Y underscore, same command, Y underscore predict. We have to predict using the predict command. We have to predict model dot predict X underscore test. I need to use. Then it is able to predict the value of the value of the Y value. Then we can go for mean squared error testing for this one. And we can find out the value for any unseen data for X price. Okay, I will complete this program and post it to, I will send you with the materials. Okay. Some data conversion error is happening. I will resolve it and I will send to you. Okay. I have used model regression model. I have used here X train only. X train, Y train only. Okay, actually the time is also completed. Okay, okay. Thank you, Kathy. That is the concept of multiple linear regression. We have to use multiple X and single Y, multiple X for predicting the value of selling price of the car. Okay. Okay. Kathy. Hello. Kathy, hello. Whether you have any yes, someone is x underscore test, it is should be actually it is a variable we have defining. It should be x underscore test only have. Before seeing this one also I have corrected that one. Please zoom your screen. Okay. Actually, I will share the entire materials to Kathy ma'am, and ma'am will share to you entire PPT and also the this notebook also, coding part also. I will correct everything and I will send to you these two notebooks also. If we have any doubts, we can ask now. Otherwise, we can conclude the session. Time is already completed. Kathy ma'am.
Hello.
Hello.
Ma'am, there are certain repositories which give the data set in tar file. So how can we convert that into CSV file?
Actually, we need to use that pandas library to convert to any type of files into the CSV file. Excel to CSV I have worked with that. Actually, I haven't worked with this type of files. Can you please send me that file to me? Then I will try to convert it and send you back.
Okay. But ma'am, I also want to I want to know the procedure. What is the procedure to make a conversion?
Actually, we have to use Excel. Actually, it should be covered. Actually, yesterday's session. Actually, it should be covered with the Tanda session. So we have number of conversion algorithms with us actually. To Excel or to CSV, like the number of functions with us. If you want, I will provide you the materials. Okay.
Okay, ma'am.
Okay. You can contact the Kathy ma'am. I will note this noting this point and I will provide the solution to you. Okay.
Okay, ma'am. Okay, ma'am.
Okay. I will provide my number here. You can also contact me if you have any doubt.
Okay.
See, that part is completely with the pandas library. I need to anyway, I have converted Excel in a number of Excel. Can you please send me that file to me? Thank you all for listening me. I will provide all the materials for you. Any further doubts?
Yes, ma'am. I will be doing that.
Okay. Okay. Please send to me. I will provide the solution for it. Okay. If you have downloaded your data set from which site, can you provide the link also? That is also possible. Can you provide the link in the chat box? Kathy ma'am.
Yes, Diana, I'm here.
Okay. Shall we conclude if there is no further doubts?
Yes. So, dear teachers, if you don't have further doubts, we can conclude the session here. And I have reshared the attendance link in the chat box. So those who have not marked their attendance yet, they can mark their attendance from the link. And Nidhi ma'am, I will be sharing the yesterday's recorded video as soon as possible. Actually, my device is not working. I have given it to the repair center, so I'll get it back today. I'll surely provide you the recorded sessions and the PDF.
Kathy ma'am, I will provide the entire notebooks and PPT with you for okay
Sure.
of my session. One doubt is here: can regression model helpful for microarray data? Can you please confirm to the data about the data set? Some question is here. Actually, it is mainly based on the type of the problem. If you want to predict a value of, then we can go for regression model. If you want to classify something, we should go for regression model. What is this one microarray data? Can you please explain with the data set with me?
Okay, any other queries? Please mention your queries in the chat box, or else feel free to unmute yourself to ask your queries or doubts.
Microarray dataset consists of gene expression values. If we consist of values, we have to confirm with the output whether the output portion is a label or a value. Can you please share with me the dataset? Then I can confirm that. Actually, we have to check for the output y value. Based on that value, if the y value, if say numeric value, we can go for regression. The y value is a label or my email ID.
Okay, Diana, let me do one thing. I'll add you to the WhatsApp group.
Oh,
And
then, it's fine, Kathy. I can this one. I can confirm with their doubts also. There, they have any doubts?
yes, exactly. And Ayush, sir, if you are there in the meeting, can we change the settings of the WhatsApp group that all the participants are able to send the messages in the group, so that they are like it will be convenient for them also to share the content in the WhatsApp group and their queries also. Like if they're practicing some code and they are facing any error, they can easily take a screenshot and they can just share in the WhatsApp group.
Exactly.
If that
That
is
would
fine,
be.
yes, if that is fine, I'll just change the settings of the WhatsApp group so that all the faculty members are able to send the messages and their doubts in the WhatsApp group. And Diana, I'll just surely add you to the group and you can share the documents with the teachers directly in the group itself.
Okay, fine. I will share the documents in the. I will upload all the files in a single drive and I provide the link in the group itself. Kathy,
Yes.
I will today itself. I will provide.
Yeah, thank you so much, Diana.
Okay, thank you. Thank you.
Okay,
Kathy.
so I
Thank you.
believe we do not have any further queries and we can conclude the session here.
Thank you, respected teachers who have attended this session. Thank you so much. Thank you, Kathy, for organizing. Thank you.
Okay, thank you, Diana, for such a wonderful session and knowledge. So thank you everyone for joining in and providing your time. I will be sharing the recorded sessions as soon as possible. I am really extremely sorry for the delay in sharing the sessions. Most probably I'll share the recorded sessions by tomorrow. Thank you everyone for joining in. Let's meet tomorrow at the same time. Have a nice evening.
Once more, thank you all. Thank you.